The December wind cut across the tarmac at Rechlin Airfield like a blade, carrying with it the scent of aviation fuel and winter rain. Klaus Hartmann stood with his hands deep in the pockets of his leather coat, watching as the ground crew maneuvered the captured aircraft into the testing hangar. The machine was enormous, brutish even, painted in the drab olive and grey of American forces. Its propeller blades caught the weak afternoon light, and despite himself, Klaus felt a flutter of anticipation. "Look at the size of that thing," muttered Werner Vogel beside him, his breath forming small clouds in the cold air. Werner was younger, barely 26, but already one of the sharpest aerodynamic engineers at the Luftwaffe testing facility. His wire-rimmed glasses were perpetually smudged, and he had a habit of pushing them up his nose when he was thinking. "It's like they bolted wings to a water tank," Klaus smiled faintly. At 42 he'd seen enough aircraft to know that. Appearances could deceive, but he understood Werner's skepticism. The Republic P-47 Thunderbolt did indeed look ungainly compared to the sleek lines of the Focke-Wulf FW-190 or the elegant Messerschmitt Bf-109. It was February 1944, and Germany was hemorrhaging pilots and planes to Allied air superiority. Every captured enemy aircraft represented an opportunity to understand what they were up against. "Herr Hartmann," a voice called from the hangar entrance. It was Major Friedrich Steiner, the facility commander, a man whose iron cross hung perpetually at his throat and whose face bore the permanent scowl of someone who had seen too much of this war. The Americans were kind enough to deliver this one mostly intact. The pilot bailed out over Belgium last week. Flak got his engine. Klaus and Werner followed Steiner into the cavernous hangar, where electric lights illuminated the Thunderbolt in harsh detail. Up close, the aircraft was even more imposing. Its radial engine cowling bulged like the chest of a bull, and the fuselage seemed to go on forever. Several other engineers and technicians had already gathered around it, their expressions ranging from curiosity to outright disdain. "American engineering," scoffed Otto Brenner, the senior engine specialist. Otto was a veteran of the previous war, grey-haired and stubborn, a man who believed German precision was unmatched in the world. He rapped his knuckles against the fuselage, sheet metal, rivets everywhere. "Look at this construction. It's crude." Klaus approached the engine cowling, running his hand along the access panels. "Crude perhaps, but functional. This aircraft has a reputation, Otto. Our pilots report that it can take tremendous punishment and keep flying." "Any aircraft can be lucky," Otto replied dismissively. He was already working on the cowling fasteners, eager to expose the engine beneath. "I'm more interested in what's making it fly at all. The reports say it performs well at high altitude. That's what Berlin wants to know about." Werner had his notebook out, sketching the aircraft's dimensions and noting details. "The wing loading must be enormous with this weight. How does it maneuver?" "It doesn't, according to our pilots," said Steiner. "It's fast in a straight line and can dive like a stone, but in a turning fight, our 109s can outturn it easily. Yet somehow the Americans keep coming back with more of them, and they keep winning." There was frustration in his voice, perhaps even a hint of fear. Over the next hour, they removed the massive cowling panels, revealing the Pratt & Whitney R2800 double wasp engine. It was a radial design, 18 cylinders arranged in 2 rows, and even silenced and cold, It radiated power. But what caught everyone's attention was the massive turbocharger installation tucked beneath the engine, connected by thick ducting that snaked back through the fuselage. Otto stared at it for a long moment, then laughed. Not a pleasant laugh, but one edged with contempt. This is their secret weapon, this turbocharger. Mein Gott, look at the tolerances. Look at these bearings. He pointed to the turbine housing. This is American mass production. Cheap materials. Loose specifications. We've been building superior superchargers for years. Klaus crouched down to examine the installation more closely. Something about it troubled him. The design was indeed simpler than German equivalents, less elegant. The ducting seemed almost haphazard, the control systems basic. But there was something else, something in the way it was all integrated. Werner, what's your initial assessment? Werner was making calculations in his notebook, his pencil moving rapidly. The turbine diameter is larger than I expected, and the intercooler arrangement is unusual. They're channeling massive amounts of air through the system. Wasteful, Otto declared. Inefficient. Our engineers would never approve such a design. Major Steiner checked his watch. Gentlemen, I need preliminary findings by tomorrow morning. Berlin is asking questions, and I need answers. Klaus, your lead on this project. Take whoever you need. I want to know everything about how this machine works, and more importantly, whether we can exploit any weaknesses. He paused at the hangar door. And Klaus? They're asking if we can replicate it. Give me an honest assessment. After Steiner left, the team dispersed to begin their detailed examination. Klaus remained by the turbocharger, studying it with growing unease. Otto's dismissiveness bothered him. In his 2 decades of engineering work, Klaus had learned that apparent simplicity often masked sophisticated solutions to complex problems. The Americans might not build things to German aesthetic standards, but they had their own logic. You're worried, Werner observed, appearing at his shoulder. I'm cautious, Klaus corrected. This aircraft has been flying combat missions at altitudes where our fighters struggle. There's a reason for that, and I don't think it's luck or crude American craftsmanship. That evening, Klaus remained in the hangar long after the others had left for dinner. He'd sent for the technical reports from Luftwaffe pilots who had engaged Thunderbolts in combat, and he spread them across a workbench, reading by the light of a desk lamp. The accounts were consistent. P-47s operating at 25,000 feet and higher, where the thin air strangled German engines. They would dive from altitude with tremendous speed, make a single firing pass, then climb back up before German fighters could respond. One report from a pilot named Hauptmann Gerhard Müller was particularly detailed. Müller had pursued a damaged Thunderbolt from 30,000 feet down to 15,000, firing until his ammunition was exhausted. He claimed at least 50 hits on the American aircraft, possibly more. The Thunderbolt had continued flying, had even gained distance on him, and had made it back across Allied lines. Müller concluded his report with a single line that Klaus found himself reading repeatedly. This aircraft should not exist. Burning midnight oil, Klaus. He looked up to find Hannah Richter standing in the hangar doorway, holding 2 tin cups of what passed for coffee these days. Hannah was one of the few women working at the facility, a mathematician and systems analyst whose brilliance had overcome even the most rigid prejudices. Her dark hair was pulled back in a practical bun, and she wore the same oil-stained coveralls as everyone else. Hannah, I thought you'd gone home, home is a cold apartment in town and an empty larder. This hangar is warmer, and the company is better." She handed him one of the cups and pulled up a stool. "So this is the famous Thunderbolt. Otto thinks it's junk. Otto thinks anything not built in Stuttgart is junk." She smiled at that. "True enough. What do you think?" Klaus gestured at the reports. "I think we're missing something. The performance doesn't match the engineering, at least not as we understand it. This turbocharger system, there's something about it we're not seeing yet." "Then we test it," Hannah said simply. "That's what we do here. We test, we measure, we learn." Over the following days, the team disassembled the turbocharger system with painstaking care. Each component was measured, weighed, and documented. Otto continued to point out what he saw as deficiencies. The turbine blades were thicker than German equivalents. The bearings had more clearance. The control mechanisms were simpler. "Look at this wastegate actuator," he said during one examination, holding up the component like damning evidence. "Mechanical linkage, primitive. Our systems are electronically controlled, much more precise, and much more prone to failure," Werner countered. He'd been growing more assertive as the investigation progressed. "I've been reviewing our maintenance logs. Our supercharger systems require constant adjustment and frequent replacement of components. These American parts look like they're designed for durability over precision." Otto's face reddened. "Durability means nothing without performance." "Gentlemen," Klaus intervened, "let's focus on getting this engine running. We need real data, not speculation." It took 3 more days to reassemble everything and connect the necessary testing equipment. The Luftwaffe had confiscated American aviation, fuel from occupied territories, enough to run proper tests. On a grey morning with snow threatening, they prepared for the first engine run. The hangar had been cleared except for essential personnel. Klaus stood at the control station they'd set up, wearing headphones connected to a microphone system. Werner was with him, monitoring gauges. Hannah had positioned herself at a separate station to record temperature and pressure readings throughout the system. Otto stood near the engine itself, insistent on being close to observe any problems. Klaus gave the signal, and the ground crew engaged the starter. The massive propeller began to turn, slowly at first, then faster as the engine caught. The radial roared to life with a deep, thunderous sound that rattled the hangar walls. Even idling, it was impressively loud. "Oil pressure normal," Werner called out over the noise. "Temperatures rising steadily. Magnetos firing properly." Klaus gradually advanced the throttle, bringing the engine up to cruise power. The sound intensified, a constant roar that made conversation impossible without the headphones. So far everything was performing normally. Then he activated the turbocharger system. The change was immediate and dramatic. The engine note deepened and smoothed out, and the gauges showed a surge in manifold pressure that made Werner's eyes widen. "Klaus, look at these readings. The boost pressure is far higher than I calculated." Hannah's voice crackled through the headphones. "Turbine inlet temperature is stable. Compressor discharge temperature is higher than expected, but the intercooler is handling it. This is remarkable." Klaus ran the engine through various power settings, from idle to near maximum, watching the turbocharger respond. The system was maintaining sea-level manifold pressure at simulated altitudes, where German engines would be gasping for air. The integration between engine and turbocharger was seamless, almost organic. After 30 minutes, he shut down the engine. In the ringing silence that followed, the team gathered around the data sheets. "I don't understand," Werner said. his voice tinged with confusion and something else, possibly admiration. The individual components aren't superior to ours. In many ways they're cruder. But the system performance is exceeding our best supercharger designs. Otto was studying the turbine housing, his expression troubled. The turbine blades show no signs of excessive stress or heat damage. But they should. At these temperatures and pressures, with these materials, they should be showing degradation. Hannah looked up from her calculations. Unless the materials aren't what we think they are. Klaus, I think we need metallurgical analysis. There's something about these alloys that we're not seeing with our eyes. Klaus felt a cold certainty settling over him. Arrange it. Take samples from the turbine blades, the compressor housing, the ducting. I want a complete material analysis. The metallurgy lab was in a separate building, run by Dr. Emil Schneider, an elderly chemist who had been analyzing materials since before the First War. Klaus brought him samples 3 days later, along with Hannah and Werner. Otto had refused to come, declaring it a waste of time. Dr. Schneider examined the samples under various microscopes, conducted spectrographic analysis, and ran hardness tests. His laboratory was cluttered with beakers, burners, and incomprehensible equipment, all of it bearing the scars of decades of use. The old man worked with the patience of someone who understood that the truth revealed itself slowly. Finally, after 2 days, he invited them back to review his findings. He spread photomicrographs across his desk, images of metal grain structures magnified hundreds of times. Gentleman and lady, he nodded to Hannah. What you've brought me is quite interesting. These alloys are not what I expected. What do you mean? Klaus asked. The turbine blades, for instance. So they're a nickel-based superalloy, but the composition is unique. The Americans have achieved a grain structure I've never seen in production materials. Look here. He pointed to one of the photomicrographs. See how uniform the crystals are. This indicates very precise control during the casting and heat treatment process. This material can withstand much higher temperatures and stresses than our equivalent alloys. Werner leaned closer to examine the images. How much? Higher, conservatively? 50 to 70 degrees Celsius higher operating temperature. Perhaps more importantly, it maintains its strength characteristics across a wider temperature range. Our alloys become brittle in the cold and lose strength rapidly in heat. This American alloy is remarkably stable. Hannah was making notes rapidly. What about the other components? Similar story throughout. The aluminum alloys in the ducting show excellent thermal properties. The steel in the turbine housing has been treated with a process I can't fully identify, but it's clearly superior to our methods. Even the bearings, which are your colleague Otto dismissed as crude, made from materials that will outlast our more precise equivalents. Klaus felt something shift in his understanding. Dr. Schneider, in your expert opinion, could we replicate these materials? The old chemist removed his glasses and cleaned them slowly, a gesture Klaus recognized as a stalling tactic. Could we? Perhaps, given unlimited time and resources. But we're not in that situation, are we? These alloys require sophisticated metallurgy, precise quality control, and most importantly, raw materials that we're currently lacking. The nickel alone, do you know how much nickel is in these turbine blades? More than we'd use in an entire engine. The Americans have access to materials we simply don't have in sufficient quantities. The implications hung in the air like smoke. Werner broke the silence. They're not building to our standards because they don't have to. They have better materials. More than that, Hannah added quietly. They've designed the entire system around their material capabilities. The crude tolerances Otto complained about. They're actually optimized for their manufacturing processes, the simple control systems. They're reliable because they don't need to compensate for material limitations. Klaus thanked Dr. Schneider and led the team back outside. The winter afternoon was fading to evening, and the airfield was quiet, except for the distant sound of a transport plane taking off. Right. They stood for a moment in the cold, none of them speaking. Finally, Werner voiced what they were all thinking. We need to fly it. We need to see what it does at altitude under actual combat conditions. The next morning, Klaus presented his findings to Major Steiner. The commander listened silently, his face growing progressively darker. When Klaus finished, Steiner stood and walked to the window of his office, looking out at the airfield where a formation of FW-190s was preparing for takeoff. So what you're telling me, Steiner said slowly, is that the Americans have built an aircraft we cannot match because they have access to materials we don't have. That's part of it, Klaus replied. But it's more than just materials. Their entire design philosophy is different. They've optimized for mass production, durability, and operational simplicity. A P-47 might require less skill to maintain than our fighters. It can take more damage. It can operate from rougher airfields. And yes, it can outperform our aircraft at high altitude because of this turbocharger system. Can we build our own version? Klaus had been dreading this question. We could attempt it, but it would require resources and time we don't have. We'd need different alloys, which means different furnaces and different raw materials. We'd need to retrain factory workers. We'd need to redesign our engines from the ground up. Major, we're talking about years of developments, and even then we'd be catching up to where the Americans already are. Steiner turned from the window. Berlin won't want to hear that. Berlin needs to hear it anyway, and the flight test. I have arranged for Hauptmann Muller to fly it. He's one of our best test pilots, and he's already fought against Thunderbolts. He'll give us an accurate assessment. The flight test was scheduled for the following week, pending weather. Klaus used the time to prepare detailed test protocols, specific maneuvers, and altitude profiles designed to evaluate the aircraft's capabilities. Hannah developed a mathematical model to predict performance based on the engine data they'd collected. Werner coordinated with the ground crew to ensure the aircraft was properly prepared. Otto remained skeptical, insisting that actual flight performance would reveal weaknesses their ground tests had missed. All the fancy materials in the world won't make up for poor aerodynamics, he declared. The day of the test dawned clear and cold, one of those crystalline winter mornings when the sky seemed infinite. Hauptmann Gerhard Müller arrived early, walking around the P-47 with a mixture of professional interest and personal grudge. He was tall and lean, with the pale skin and dark circles under his eyes that marked so many combat pilots these days. "So, this is the beast that keeps killing my friends," he said, running a hand along the fuselage. "She's ugly up close, isn't she?" "Ugly, but effective," Klaus replied. He handed Müller the test protocol. "We need specific data on high-altitude performance. Take up to 30,000 feet if you can, then run through these power settings and maneuvers." Müller studied the document. "You want me to find her limits? I want you to find out if she has any." The preflight took an hour. Müller was meticulous, checking every surface, every control, every gauge. Klaus appreciated the professionalism. Finally, Müller climbed into the cockpit, and ground crew helped him strap in. The canopy closed with a solid thunk. The R2800 engine started with its characteristic roar, and after a brief warm-up, Müller taxied to the runway. Klaus, Werner, and Hannah watched from the control tower, equipped with binoculars and radio equipment. Otto had positioned himself in the hangar, monitoring telemetry equipment they'd installed in the aircraft. Muller's voice crackled over the radio. Rechlin Tower, test aircraft ready for takeoff. Test aircraft, you are cleared for takeoff. Wind is 270 at 8 knots. The Thunderbolt began its takeoff roll, accelerating with surprising speed for its size. The tail came up quickly, and then it was airborne, climbing steadily. Klaus watched it through binoculars as Müller retracted the landing gear and continued climbing in a wide circle around the airfield. Altitude 5,000 feet, Müller reported. Engine temperatures normal. Manifold pressure 42 inches. She climbs like she's late for a wedding. Hannah was calculating climb rates. He's averaging almost 3,000 feet per minute. That's faster than a 109 at this weight. The aircraft continued climbing, shrinking to a distant speck against the blue sky. Müller's reports came at regular intervals, his voice remaining calm and professional. 10,000 feet, 15,000, 20,000. At each altitude, he ran through the test protocol, noting engine performance, control response, and handling characteristics. 25,000 feet, Müller reported. Engaging full turbocharger boost. Mother of God, listen to this engine sing. I've got full power up here. Full power, do you understand what that means? Klaus understood perfectly. At 25,000 feet, a Bf-109 would be struggling, its engines starved for oxygen, its performance degraded. But the Thunderbolt was operating as if it was still at sea level. Engine temperatures, Klaus asked into the radio. All green. Everything is green. She's barely working. There was wonder in Muller's voice now, the grudging admiration of a professional recognizing excellence. Beginning combat maneuvers. For the next 20 minutes, Müller put the P-47 through its paces at altitude. Steep turns, high-speed dives, zoom climbs, everything a pilot might need in combat. He reported each maneuver, describing how the aircraft responded, where it excelled, where it struggled. She's no dancer, Müller reported. In a slow-speed turning fight, a 109 would still have the advantage, but Herr Hartmann, she doesn't need to turn. She can dictate the fight. Dive on the enemy, attack, then zoom climb back to altitude. The enemy can't follow. I couldn't follow when I was on the other side. Now I understand why. Hauptmann, take her to 30,000 feet, Klaus ordered. Maximum altitude test. Understood. The climb to 30,000 took several more minutes. At that altitude, the air was so thin that unprotected pilots risked losing consciousness. Müller's breathing was audible over the radio, slightly labored despite the oxygen mask. 30,000 feet, he finally reported. The world looks very small from up here. Engine is still running strong. I have complete control authority. In my 109, at this altitude, I'd be barely holding position. This aircraft, he paused. This aircraft owns the sky up here. Klaus exchanged glances with Werner and Hannah. They had suspected, but confirmation still carried weight. Hauptmann, begin your descent. Run the high-speed dive test on the way down. With pleasure. Müller put the P-47's nose down and let gravity do its work. The airspeed indicator climbed rapidly as the aircraft accelerated. 200 knots, 300, 400. Müller's breathing grew heavier as G-forces built up, but his voice remained steady. 450 knots indicated. Controls are solid. No flutter, no vibration. She's stable as a church. A pause. 480 knots. This is faster than I've ever gone. Leveling off at 15,000 feet. The pullout from the dive was smooth, the aircraft responding immediately to control inputs. Müller spent another 20 minutes at lower altitudes, testing landing characteristics and slow-speed handling, before finally bringing the Thunderbolt back to Rechlin for landing. The touchdown was firm but controlled, and Müller taxied back to the hangar with the same professional precision he'd shown throughout the flight. When he climbed out of the cockpit, his face was flushed from the cold and the exertion, and his flying suit was dark with sweat despite the frigid temperature. But his eyes were bright with a particular intensity that came from experiencing something significant. Klaus met him at the base of the ladder. "Your assessment, Hartmann." Müller removed his leather helmet and ran a hand through his sweat-dampened hair. "Herr Hartmann, I've been flying fighters since 1939. I've flown everything the Luftwaffe has. I have flown captured British Spitfires. I've flown the latest FW-190 models." He looked back at the P-47. "This aircraft is in a different category. It's not better at everything. I could outturn it in a 109, outroll it in a 190. But where it matters, at high altitude where the real air war is being fought, it's superior to anything we have. And it's not close." Otto had emerged from the hangar looking pale. "The telemetry data confirms everything he's saying. The engine performance at altitude is extraordinary. We have nothing that can match it." That evening, Klaus compiled his final report. He sat at his desk in the officers' quarters, a single lamp illuminating the papers spread before him. Outside, he could hear the sound of aircraft returning from operations, the rumble of engines that suddenly seemed inadequate. Hannah found him there well past midnight, still writing. She sat down across from him without asking. "You're writing the report that ends the questions. I'm writing the truth. Whether it ends questions or raises new ones, that's not for me to decide. What will you tell them?" Klaus set down his pen. "I'll tell them that the Americans have solved the high-altitude problem in a way we can't replicate with our current resources. I'll tell them that it's not about any single component being superior, but about a complete system designed around different principles. I'll tell them that their industrial capacity allows them to use materials and methods we can't match." He paused. "And I'll tell them that this aircraft represents not a technical achievement, but a fundamental difference in approach. They won't want to hear it, no, but they need to." Hannah was quiet for a moment. "Otto is talking about sabotage. He's saying the Americans must have stolen German research, that there's no way they could have developed this independently." Klaus felt a surge of frustration. Otto is a brilliant engineer trapped in a narrow worldview. The Americans didn't steal our research. They didn't need to. They approached the problem differently, with different constraints and different advantages. That's the lesson here, if anyone will listen. Will they? Listen, I don't know. Klaus looked at the partially written report. "But I have to try." The final report was completed over the next 2 days, with contributions from Werner, Hannah, and even, grudgingly, from Otto. It was comprehensive, technical, and brutally honest. Klaus documented every test, every measurement, every conclusion. He included Dr. Schneider's metallurgical analysis, Muller's flight test reports, and Hanna's performance calculations. The picture that emerged was clear. The P-47 Thunderbolt represented a significant technical achievement that Germany could not quickly counter. Major Steiner read the report in silence, his expression growing steadily grimmer. When he finished, he set it down carefully, as if it might explode. "Klaus, you understand what you're saying here. You're telling Berlin that the Americans have out-engineered us. I'm telling Berlin the truth about what we've found. What they do with that information is their decision. They'll want solutions, not problems. Then tell them the solution is to develop our own high-altitude capabilities, but that it will take time and resources we may not have. Tell them that, in the meantime, we need to change our tactical approach. Avoid high-altitude engagements where the P-47 has the advantage." Klaus leaned forward. "Or tell them nothing, and watch more pilots die wondering why they can't catch the Americans." Steiner was quiet for a long moment. Finally, he picked up the report. "I'll forward this to Berlin. But Klaus, be prepared for pushback. There are people in the ministry who won't want to hear this." The pushback came within a week. A telegram arrived from the Reich Air Ministry, summarily dismissing Klaus's findings and demanding a revised report that focused on weaknesses rather than strengths. The message was clear: tell us what we want to hear, not what is true. Klaus read the telegram twice, then set it on fire in an ashtray. Werner and Hanna watched the paper curl and blacken. "So that's it then?" Werner asked. "They don't want the truth." "They want a truth they can live with," Klaus replied. "But I won't give them a false one." The report stands. Over the following weeks, word of the Thunderbolt evaluation spread through Rechlin and beyond. Pilots asked questions, other engineers wanted to examine the aircraft. Slowly, almost imperceptibly, attitudes began to shift. The crude American design was reassessed, not as inferior, but as different, and in some crucial ways, superior. Otto finally admitted, during a late-night conversation in the hangar, that he'd been wrong. "I let my pride blind me," he said. "Staring at the P-47, I saw what I wanted to see: crude design, poor tolerances, cheap construction. I didn't see the intelligence behind it, the optimization for their strengths rather than our standards." Klaus appreciated the admission. We're all guilty of that sometimes. Seeing what we expect rather than what's there, what happens now. To the aircraft, I mean. Steiner is arranging for it to be sent to other facilities for evaluation. More people need to understand what we're facing. Klaus patted the fuselage, and maybe, just maybe, it will inspire some different thinking about how we approach our own designs. In March, Klaus received orders to report to a meeting in Berlin. He went with trepidation, expecting censure or worse. Instead, he found himself in a room with other senior engineers and several high-ranking Luftwaffe officers. The discussion was frank, sometimes heated, but ultimately productive. His report had circulated more widely than he'd realized, and while some rejected his conclusions, others recognized their validity. "The question," said General Oberst Eckhard Ritter, a grizzled veteran of both wars, "is not whether the Americans have built a good aircraft. Clearly they have. The question is what we do about it." Klaus was asked to present his findings directly, which he did with the same honesty that had characterized his written report. He explained the turbocharger system, the materials science, the integrated design philosophy. He showed Müller's flight test data and Dr. Schneider's metallurgical analysis. When he finished, the room was silent for a moment. Then Ritter spoke. "So we cannot match this aircraft with our current resources." "Very well. Can we counter it tactically?" "Yes, sir. The P-47 has weaknesses. It's not agile at low altitudes. It requires long runways. It's vulnerable during takeoff and landing. But in high-altitude combat, where it can dictate the engagement, it's extremely dangerous. Then we avoid high-altitude combat where possible, and we develop tactics to exploit its weaknesses where we cannot." Ritter looked around the room. "Gentlemen, Herr Hartmann has given us valuable intelligence. Let us not waste it by refusing to accept reality." Klaus returned to Rechlin with a strange mix of emotions. His report had been accepted, at least by some, but the larger implications troubled him. Germany was fighting an enemy with superior resources, superior materials, and increasingly superior technology. The Thunderbolt was just one example, but it represented a pattern Klaus had been seeing in other captured equipment as well. Werner noticed his mood that evening. They were walking back from the officers' mess, the spring air finally showing hints of warmth. "You're thinking about the war," Werner said. "It wasn't a question. I'm thinking about what this all means," Klaus replied. "The Americans aren't just building good aircraft. They're building thousands of them. Their pilots aren't just brave. They are well trained and well supported. Their industry isn't just large, it's sophisticated and efficient." He stopped walking. "Werner, we're engineering ourselves, analyzing captured equipment, writing reports, but the outcome seems increasingly inevitable." Werner was quiet for a moment. "Then why do we keep doing it?" "Because it's what we know how to do. Because those pilots up there deserve the best information we can give them. Because even if the outcome is inevitable, we still have a responsibility to the truth." Klaus started walking again. "And because maybe, just maybe, someone will learn something from all this that matters after the war is over." The Thunderbolt remained at Rechlin through the spring, becoming an unlikely fixture on the airfield. Pilots came to examine it, ground crews studied its systems, engineers measured and remeasured every component. It became, in its way, a teacher, a silent testament to different ways of solving problems. Hannah spent hours analyzing the data from their tests, developing mathematical models that predicted how future aircraft might perform. "Look at this," she said one day, showing Klaus a series of calculations. "If we extrapolate the American approach, if we assume they continue developing along these lines, in 5 years they could have aircraft operating at altitudes we can't even reach, speeds we can't match. It's not just about this one airplane. It's about a trajectory." Klaus studied her figures. She was right, of course. The P-47 wasn't an endpoint, but a milestone. Then we need to change our own trajectory. But that requires resources, time, and a willingness to learn from others rather than just competing with them. "Do you think we will? After the war?" "I mean, I hope so. I hope we remember this lesson, that engineering isn't about national pride or proving superiority. It's about solving problems, and the best solutions come from understanding the problem clearly, not from assuming we already have all the answers." In May, Klaus received word that the Thunderbolt was being moved to another facility for continued evaluation. Its time at Rechlin was ending. He went to the hangar early on the morning of its departure, wanting a few moments alone with the machine that had taught him so much. The aircraft sat silent in the pre-dawn light, its olive paint gleaming dully. Klaus walked around it one final time, trailing his hand along the fuselage, remembering that first day when they'd dismissed it as crude and simple. How wrong they'd been. Not wrong about the surface details. Those observations had been accurate enough. But wrong about what those details meant. Wrong about the intelligence behind the design. Wrong about their own assumptions. Müller found him there. The pilot had flown the P-47 several more times over the past months, each flight adding to his respect for the aircraft. Saying goodbye, he asked. Something like that. This aircraft changed how I think about engineering. Changed how I think about combat, Müller replied. He stood beside Klaus, both men looking at the Thunderbolt. You know what scared me most about flying this? It wasn't the aircraft itself. It was imagining facing hundreds of them, piloted by well-trained Americans who understood how to use its advantages. That's what we're up against. Yes, Klaus agreed simply. There was nothing more to say. The ground crew arrived to prepare the aircraft for its ferry flight to the new facility. Klaus and Müller stepped back, watching as the propeller began to turn, the engine catching and roaring to life one final time. The sound filled the hangar, powerful and confident, a mechanical voice that spoke of capability and purpose. As the Thunderbolt taxied away toward the runway, Klaus felt Werner's presence beside him. The young engineer had tears in his eyes, though whether from emotion or the wind, Klaus couldn't say. It's just an airplane, Werner said, not sounding convinced of his own words. No, Klaus replied, watching the aircraft take off and climb into the morning sky. It's more than that. It's a lesson. It's a mirror. It's a reminder that we don't have a monopoly on intelligence or innovation. He turned to Werner. The question is whether we'll remember that lesson when it matters. The Thunderbolt disappeared into the distance, becoming a speck against the clouds, then vanishing entirely. Klaus stood watching the empty sky for a moment longer, then turned back toward the hangar. There was more work to be done, more aircraft to evaluate, more reports to write. The war continued, regardless of the lessons learned or the truths discovered. But something had changed in Klaus Hartmann. He had confronted his assumptions and found them wanting. He had examined what he thought was crude and discovered sophistication. He had looked at American engineering with German eyes and learned to see it on its own terms. It was a small change, perhaps in the context of a world at war. But for an engineer who valued truth above all else, it was everything. In the months that followed, Klaus continued his work at Rechlin, but with a different perspective. He pushed his team to question their assumptions, to look beyond surface appearances, to understand that excellence could take many forms. He advocated for new approaches, even when they contradicted traditional German methods. Some listened, many didn't, but he persisted, driven by the memory of that brutish American fighter and the lessons it had taught. The war, of course, ended as Klaus had feared it would. Germany's defeat was total and devastating. But in the ruins of that defeat, in the painful process of rebuilding and rethinking, some of those lessons survived. Engineers who had worked at Rechlin, who had examined captured Allied equipment with honest eyes, carried forward a new understanding of what engineering could be, not a competition of national pride, but a collaboration of human ingenuity. Years later, Klaus would reflect on those months with the Thunderbolt as a turning point, not just in his career, but in his understanding of the world. The aircraft had been more than a machine to evaluate. It had been a teacher, offering lessons about humility, about the dangers of assumptions, about the many paths to solving problems. And sometimes, late at night, when he couldn't sleep, Klaus would remember the sound of that R2800 engine roaring to life, the sight of the Thunderbolt climbing effortlessly into the thin air where German fighters struggled, and he would smile sadly at the memory of his younger, more arrogant self who had dismissed it as crude American engineering. That self had died in the winter of 1944, killed by truth and measurement and honest observation. What replaced it was harder to define, but infinitely more valuable. An engineer who knew that the best designs often came from unexpected places, that sophistication could hide behind simplicity, and that the willingness to learn from others, even enemies, was not weakness, but wisdom. The Thunderbolt had taught him that, and it was a lesson he would carry until his final days.